Welcome to Precalculus Concept 14b. We're going to use synthetic division to divide polynomials, and there's only 3 boxes. So here's box number 1. We're going to start by talking about how synthetic division works. But before we do that, I want to refresh your memory and do a long division of polynomials problem with you, just as a review. So over here I've got x to the third plus 4x squared minus 5x plus 5, all divided by the quantity x minus 3. We're in good shape because we can see that we've got our exponents lined up in descending order, 3, 2, 1, and 0. So we're going to go ahead and divide this using long division. So x goes into x to the third, x squared times x gives me an x to the third. X squared times negative 3 is negative 3x squared. Draw a line, subtract the entire amount. So x to the third minus x to the third is 0 by design. 4x squared minus a minus gives me 4x squared plus 3x squared, which gives me a positive 7x squared, and bring down my negative 5x. X goes into 7x squared, a positive 7x times. 7x times x gives me 7x squared. 7x times negative 3 is negative 21x. And again, I'm going to put parentheses around here and subtract. 7x squared minus 7x squared is nothing. Negative 5x squared minus a minus. Don't forget to distribute that sign. So negative 5x minus a minus gives me negative 5x plus 21 gives me a positive 16x. And then again, bring down the 5. Okay. X goes into 16x, a positive 16 times. Moving on up here. 16 times x gives me 16x. 16 times a negative 3 gives me a negative 48. Okay, subtract all this stuff again. So subtract 16x minus 16x gives me nothing. And then 5 minus a negative 48 would give me a positive 53. So my remainder is worth 53. Okay, that was an example of long division, and we should have that part down. Now, let's do the same exact problem using synthetic division. So here is the setup. I want to take a look at all of the leading coefficients of each, or the coefficients of each of my terms here. Okay, so I'm going to set up a 1, a 4, a negative 5, and a 5. All right. Then I want to take a look at my c part of my x minus c. I have an x minus 3 here, so I'm actually going to take the opposite of that one and put the number 3 on the outside here. And you're going to see why in a minute. So here's the setup. So I take the coefficients. I have 1, 4, negative 5, and 5. I take the opposite of the form of my x minus c, which is going to be in this case 3. And now I'm going to skip a line and draw a line. Skip a line and draw a line, and I'm going to put a plus sign here. This is going to be very, very strange, but you're going to hopefully notice something. So I'm going to bring the 1 down. Okay, so there's my 1. All right? I'm going to multiply my 1 with my 3 and get the number and put it here. 1 and 3. So I multiplied 1 times the 3, and I put it down over here. Okay? That gives me a total of, if I add these together, I get 7. So far, I've created a 1 and a 7. Do you see a 1 and a 7 anywhere? It's getting there, right? Okay, 7 times 3, that's going to give me my 21. If I add vertically, notice I'm going to get a 16 here. Anybody see a 16 anywhere? I see a 16 somewhere. And then a 16 times 3, that was my 48. Okay, and if I add vertically 5 and 48, notice I get 53. Wow. So what have we figured out here? This is my constant term. This is my x term. This is my x squared term. And this is my, oh shoot, hold on, I messed this up. I'm sorry guys, this is my remainder, this is my constant term, this is my x to the first term, and this is my x squared term. My bad. So, synthetic division, you can clearly see, is a much faster process than doing all of this work here, and it gets you the same result. However, it's very, very limited. It only works when you are dividing any polynomial by x plus or minus a constant value. So it only works when you're doing something like this. It cannot work if you're dividing two polynomials in which one of the your dividend or your divisor has an exponent that's bigger than 1. So it's very, very, very limited, but it's also very, very powerful. So this is the idea of how it works. I'm going to do some examples of this and then later on in the lesson. Okay, here's box 2. Let's do an example together. I'll show you the setup. So I have this polynomial, 5x to the third plus 6x plus 8 divided by x plus 2. All right. So let's take a look at the setup. We want to take all the coefficients of my dividend. So I'm going to take a 5. Notice I don't have an x squared term, so I need to put in a placeholder for an x squared term. So I have a 5, I have 0x squared, I have a 6 from my coefficient right there, and then I have an 8 for my constant term on the end. Then, if I'm dividing by x plus 2, then I'm going to take the opposite and put it on the outside here, so negative 2. All right, skip a line and draw a line, and I'm going to add this together. So there is the setup. It's very important that you keep your placeholder there. Okay, so let's start. Bring the 5 down. Okay, 5 times negative 2 is worth negative 10. 0 plus negative 10 is just worth negative 10. Negative 10 times a negative 2 is a positive 20. Adding vertically, I get 26. If I take 26 and I multiply it by 2, we get a negative 52. And then we're going to add vertically. So we're going to take 8 and subtract 52. And we're going to come up with negative 44. So what does this mean? That means that this is my remainder, this is my constant term, this is my x term, and this is my x to the power of 2 terms. So what's happened here is this. If I take 5x to the third plus 6x plus 8, and I divide it by an x plus 2, what I get is this. 5x squared minus 10x plus 26 with a remainder of negative 44. That's what that means. So that's how we use synthetic division to divide polynomials. Okay, we'll do one more example together just to make sure that you have it. So here's the setup. We're going to take a 1, because I have for my 1x to the third. I have no x squared term, so I can put a 0 there for a placeholder. I have a negative 7, and then I have a negative 6. And I'm dividing by an x plus 2, so I'm going to take a negative 2 and put it on the outside. And then I'm going to skip a line and draw a line and put an addition sign here. Let's bring the 1 down. Okay, so what's 1 times negative 2? It's worth negative 2. Add vertically, I get negative 2. Negative 2 times negative 2 is a positive 4. Add vertically, negative 7 plus 4 gives me negative 3. Negative 3 times negative 2 is a positive 6, and I get 0 as a remainder. This is going to be very, very cool coming up. This is going to tell us something very interesting. But so my remainder is 0, this is my constant term, this is my x term, and this is my x squared term. So if I take x to the third, and I subtract 7x, and I subtract 6, and I divide by x plus 2, the answer in which I get is x squared minus 2x, minus 3 with a remainder of 0. Sorry that took so long. Okay, we'll do more practice of this in class tomorrow when we see each other.